Hello guys, in this video I'm going to show you the image segmentation with k-means in Matlab. So how can we use that algorithm in Matlab? That is what I'm going to show. So I have explained this algorithm in this particular video, image segmentation by k-means. So if you have not seen this video, you can see that where I've explained the algorithm. So you can see that video. You can click it over here if you want to see that video. So let's get started. So this is the algorithm that I'm going to implement in Matlab. So what I'm doing now is I'm in debug mode. I'm going to execute line by line the code and tell you what each line is doing basically. Right, so let's get started. So initially I have kept a threshold on the number of iterations. So you can see that the stopping criteria, we have a lot of stopping criteria. So one of the stopping criteria is stop till a certain number of iterations have completed. So this is what that threshold is. So I'm saying that only go till 20 iterations. When 20 iterations are done, stop the algorithm. Or I can keep a threshold on J. So we'll see what this threshold is. It is basically based on the cost that we are defining over here. So I'm keeping the value of small n as 20 and n1 as 5. So that is the threshold that we have done. So now I'm reading this image. So I'll show you which image it is. It is that same image that I used in the video. So these balls image, right? Now here I've taken the size of the image. So b is a vector. So you can see that it is a three-dimensional vector. So this is a color image. So it has a r plane, a g plane, and a b plane. Then I'm multiplying the b1 and b2, that is rows into columns. So that will give me the total number of pixels in this image. So n1 over here is total number of pixels in this image. So there are these many pixels in this image. Now taking the input of k. So that is important because I have to initialize the k means. So I don't I'll have to tell the algorithm how many k's do I want. So that is what. So let me take it 10 for this example. And now what I'm doing is I'm converting the uh, image to double so that I can do mathematic operations on it. Okay, so now I have converted the image to double. I have taken the size. I know what are the number of pixels. Now I'm going to create this vector first. So yeah, this vector capital X, where rows are the number of pixels and the columns are the three planes RGB. So this is this particular thing is for that. So I'm creating an empty array x1, x2, and x3. And now what I'm going to do is for 1 to b2. So b2 is the number of uh, columns. So for 1 to b2 in x1 I'm going to put all the first plane, that is all the r pixels are going to come in x1. Similarly, all the green pixels are going to come in x2. Green pixels are going to come in x2, and all the red pixels are going to come in x3. So that is what is happening over here. So let me just continue this. Right, so you can see that over here we have all uh, number of pixels, that is total number of pixels, and this is 1. So this is the first, the red image. So the red pixels, all the red pixels, this is better. So all the r1, r2, r3 up to r capital N is in x1. All the g1, g2, g capital N is in x2, and b1, b2, b capital N is in x3. And I'm concatenating it together. So now in X I have the full X matrix, right? So here you can see this is the first pixel R1, R2, R1, G1, B1, R2, G2, B2, as mentioned in the algorithm. R1, G1, B1, R2, G2, B2. So the same thing I have found it over here. So this is my X matrix, right? Now we are going into the algorithm. So the first step of the algorithm is to initialize the k-means. So this is what I'm doing over here. So I have this function rand. So this function will give me random values in between 0 and 1. So rand gives you random values in between 0 and 1. This is the number of columns that you want, and this is the number of rows. This is the number of rows that you want, and this is the number of columns that you want. So if I give you an example of this function, so now that I have input the value of k, so you can see k is equal to 10. That is what I have inputted. Now if I run this particular thing, you'll see that this is giving me an array of one row because I had written one over there. So let me show you this. Right, so I had written one over here, so this gives me one row and k columns, so that is 10 columns. So that is what it is giving me, and this is all random values in between 0 and 1. So this rand function by default gives values in between 0 and 1. Now if I multiply it with 255, it will give me random values in between 0 to 255. So that is what is happening over here. So I'm doing it this for the three planes, that is the R plane, the G plane, and the B plane. So in ix1 I have randomly initialized the R values. So right, right, so this rm1 is this rm2, rm3, rm4, rm5, like this. So these are all R means, the R values of the means. Similarly, ix2 has the G values of the mean, gm1, gm2, gm3, gm4, and this has the blue bm1, bm2, right? So that is what is there over here, and then I'm concatenating everything into this mean matrix. So let me come here. So now I have this mean matrix over here, and this is precisely what I wanted. So rm1 is this rm1, rm2, rm3, rm4 up till rmk, gm1, gm2, gm3 up till gmk, and bm1, bm2 up till bmk. So this is my mu matrix, that is mean matrix, and I have the x matrix initially. So now let us see how the pixels are there in 3D. So this loop is to see the x matrix basically. So let us see that. So this is the same plot that I had shown in the video. So this is how the pixels are distributed in the three-dimensional space. So this is that. Okay. So now the main loop is going to start. That is, the main algorithm is going to start. This algorithm. So these are some variables for the algorithm. So I1 is counting how many iterations have passed. So while I1 is less than n, remember n is the total iterations that I want. So I just want 20 iterations for now. So till I1 is less than 20, this particular while loop will work. And this j is my cost, j1, this is my cost that I'm going to calculate. So let us go into the loop, right? So RNK is a matrix that I'm going to create. This is the RNK that I'm going to create. So let us see what is that RNK also. And there's going to be a distance matrix. So that is this D. I'll tell you what is that. So now what is happening is for I to N1, that is for all the pixels in the image, for all these. So okay, let me explain you that from this plot. This is better. Yeah. Right, so there are the different the pixels are there in this 3D space. Now what I'm going to do is, let me also plot the means so that I can show you better, right? These are the means. Right, so this plot that you see now is the red things are the mean values, the random initialized mean values, and the blue are the pixels, the pixel location. So what we have to do is, first we have to find the distance of every pixel with its nearest mean. So we have to find out which pixels belong to which mean. So that is what we are going to do over here for I is equal to 1 to n1. So I is going to keep track of all the pixels. So this I is for the X, the data matrix. So the data matrix has all the pixels. These are the total number of pixels that we have. And J is going to keep track of the means. So we have K means. So that is going to keep track of this means. We have 10 means. So K is equal to 10 over here. And what I'm going to do is for every pixel, I'm going to take the distance. So this is the distance formula, the L2 norm basically. So I'm going to keep the distance and put that distance in this D of I comma j. So when I execute this particular thing, let me execute this first and show you. Oh, this will only be for one loop. So this takes a little time because there's a lot of iterations that it has to do. Right. So if you see the D matrix, so this D matrix is uh, total number of pixels into 10, that is K, number of pixels into K, n cross K. And this is telling you the distance of each pixel. So this is the first pixel, suppose. So the first pixel distance with the first mean is over here. First pixel distance with second mean, third mean, fourth mean. So like that, each pixel's distance with the 10 means are shown in this particular matrix. Now what I want is, I want to just calculate the minimum distance, whichever, so here this matrix tells me the distance of all the pixels with respect to all the K means. Now I have to find out the minimum distance because I want to allocate the pixels to that particular mean, right? So that is what I will do with this thing over here. So now my min function was not working due to some problem. I don't know, there's some problem in the Matlab. So I'm using max and then putting a minus sign over here. So you know that if there are numbers, say so if there are numbers 5, 6, 7, 8, so the minimum of this is 5, right? So if I just take the negative of these, so then the maximum will be minus 5. So that is what I'm doing. So I'm taking the maximum of the minus distances so that I get the minimum distance. And this minimum will have the distance that this particular minus 5, that is, and I mean will tell me which is that index. So this index is important. I want to know which pixel is close to which mean. The distance is not important. So this min value is of no use. The distance is important. So that is sorry, the distance is not important, the index is important. So this I mean is something that is important. So for that R and K of I comma I mean, I am putting value 1. So if you see the R and K matrix, so this R and K matrix is showing which is the minimum distance of which pixel. So the first pixel, you can see it is close to the third mean because this is 1 over here. Similarly, the sixth pixels are also close to the third mean. So this is the assignment operation that I'm doing. So you can see there are a lot of pixels that are allocated to the third mean over here. When you go further, oh, there are a lot of pixels for the third mean. And right, so okay, here also there are third mean. So this third mean is very close to a lot of pixels. And when you go a little further, see these pixels are close to the second mean. So this is the RNK matrix. These pixels are close to the fifth mean, the first mean, so like that, right? So this is the RNK matrix that I have formed. So this thing is done. RNK, this particular step is done. Now that this thing is done now, so this is the cost. Now the next thing that I want to do is, once I have allocated the means, allocated the pixels to the mean, the next step is to find the cost. So that is one thing that we are going to do, and the other thing is to update the means. So to update the means, we need this particular denominator, that is the sum of or RNK. So sum of RNK means the column, the row wise sum of all the elements. So that will tell me how many pixels have been allocated to the first mean, how many when I sum all these rows. Then when I sum all these rows, how many pixels allocated to the second mean, third mean, fourth mean, and like that. So that is the sum RNK that I'm going to calculate. So that is over here, and here I'm going to calculate the cost. So the cost is the total distance of all the pixels with its nearest means addition. So that is what is calculated over here. So if you see the formula, there are two summations, n is equal to 1 to capital N, n is equal to 1 to, oh, this is a small mistake, there should be a k over here. So sorry for that, there's this small mistake, there's k over here. I'll update this and upload this PDF. So there's this small k should be over here, right, because there's this mu k over here. So this is small k from I to capital K. So over here I am keeping a loop for I to n, so that is um, taking care of this summation, the outer summation, and this j is taking care of the inner summation. And there is this distance thing that I'm going to multiply and get the cost. So J1 is my total cost, and here I'm also calculating the sum RNK, that is the denominator. Here this denominator is what I'm calculating over here, right? So here I get this and this. Now I need the numerator. So this numerator is nothing but RNK into XN. So that is precisely what I'm doing, RNK into XN. Let me put that in the side so that I can, yeah, so that I can explain nicely, right? So RNK into X is what is the numerator, and that goes into this loop. Now there is this problem here that happens is, there are sometimes what happens is, say if a particular mean is very far, say because these are, at the first place it is initialized. So if you see this particular mean, this is very far from the data. So what happens is, sometimes a particular mean does not get any pixel. So this mean is so far that it is that no particular pixel has minimum distance with this. So there is no pixel allocated to this particular mean. So what happens is, for that RNK values will be 0, because so if yeah, so say if you see the sum RNK, I guess the sum RNK is done, or it is not done. No, it is not done. So let me first show you. If suppose there is a case over here, then that will be right. Yes, you can see over here this particular thing. So this sum RNK is basically telling you how many pixels are allocated to that particular mean. So 3883 pixels are allocated to the first mean. These many pixels allocated to the second mean. So over here you can see there are 0 pixels allocated to the fourth mean. So I guess that is this particular mean, which is very far. So for this particular mean, you can see there is no pixel that is allocated. That is because this was a random initialization, and randomly the means have been placed. So this mean became so far that no pixel is very close to this particular mean. So you can see that sum RNK is 0. So for these cases, for when the sum RNK is 0, the denominator will be 0, and this particular the mean value of that particular mean will become infinity. So that is a problem that we face over here. So it is very important to keep this condition. So there is two things. First thing is, when you extract the RNK into X, so this RNK for that particular mean, for this say fourth mean, the RNK values are always 0, because of, so hence the sum is becoming 0, because all these row values in that RNK is 0. So RNK into X also gives 0. So this temp becomes all zeros, and if that is the case, then you get that infinity problem. So if that is the case, don't do anything, else update the means. So now the mean will be updated for all the other values, but it will not be updated for the fourth mean. So this fourth mean is going to be there forever. So that is one drawback that is going to happen. This fourth mean, because it is very far away from the data, so this is never going to get updated, and this will always remain like this over here. So that is one problem that we face in this algorithm. So that is what is happening, and here this particular loop will update the mean position and give it to you. So that is what is happening, and here so you have the denominator and you have the numerator. Just divide the numerator with the denominator and you will get the updated position of the mean. So that is what I've done over here. So here this condition is also important. If it is not equal to 0, then only you divide, or else you get the infinity problem, right? So after that, you can see that now you have updated the means. Now you can check the condition. Now this condition is for the cost. So I am putting the cost in the J1 variable. So over here, if you see the J1 variable, so now initially I have kept this 0 because this is like the 0th iteration and this is the first iteration. So now what I'm going to do is I'm going to check the difference, that is how much is the difference between the cost in between the two iterations. And if this difference is in between a particular threshold, then I can say that I will stop the algorithm. So that is what. So this is what is this is the threshold for that phi. So if the difference between the cost is less than phi, then I'll say the algorithm to stop. So then you will say break. So that is what is it is going to do. And now the first iteration has been completed. Now let us see what has happened now. So these plots that are over here, so let me continue till here, right? So what I'm going is I'm going to plot the whole data, then on that I'm going to plot the means as I did over here. So first plotting the data, so there is this hold on function. The hold on command holds the plot for you, and then you can plot something else over this plot. So that is this hold on function. Also the scatter 3 is for the 3D plot. So that is what I've given labels, and so these things over here tell me how do I want the points. So dot means I want each point to be a dot. So that is and B means blue color. So everything will be blue color. And the means are filled. So filled means it gives a little you see these are little big. So that is filled, and red color, so that I can differentiate in between them. And then over here I'm plotting the means in different colors. So I'm showing which particular area, which pixel has been allocated to which mean. So that is going to come over here. So that is what I'm plotting over here in this particular loop, and plotting the means on the top of that, and showing the image. So at the first iteration, how will the image look after the first iteration? So just putting the, so there is this out matrix in which I'm going to put the output image, and in that I'm going to put that mean location. The so r value will be the mean of r value, so rm1. So this thing, so after the things have been segmented, I'll put for all the pixel values that I've allotted to say rm1, the pixel value will now be rm1, gm1 and bm1 for all those pixels who have been allotted for the first mean. For the second mean, these values, like that. So that is what this loop is doing. So let me continue and show you how the results work. Right, so if you see, these are the initial pixel allotment. So you can see this particular mean is left out. This mean is very far from each other. So this was that fourth mean that is left out. So this is very far from each other. So it is not getting any pixel. So that will always remain there forever. So, and these are the different colors that are showing the different pixels that have been allocated to the different means. And this is the initial segmentation. After first iteration, this is what is the segmentation. So you can see this is also quite nice. After first iteration also, you have seen that you can at least separate the foreground from the background. So this background has become one color and the foregrounds are the other color. So you can very nicely separate the foreground and the background in the first iteration. So now let us run it through few other iterations to see how does this change with respect to iterations. So I am pressing continue, so it will again run till this point. So it will run till the second iteration and show the values. So that is what it is going. Also I am displaying the cost. So this is also what so just to see how the cost is decreasing. So you can see this cost at the first iteration was 6.3 into 10 raised to 8. Now it is 2.77 into 10 raised to 8. So you can see how much the cost has reduced. Now this is for the second iteration. So you can see a lot of difference in between the first and the second iteration. So these values were very noisy over here. This has now nicely become orange, and these were also quite ambiguous, but they are slowly shifting. So the means are slowly shifting, you can see. So that is so as and when you press continue, you will see that the different at different stages of the iteration, you can see the image, and you can now play with the different values of k and check out. You can play with different images. So now you can see this image. It is after the third iteration. So this is the first iteration. So you can see a lot of differences now. So this has become orange. Nice. So when you keep on iterating, you will see a very nice image, a very good segmented image, something like this. Uh, at after the 20 iterations or whatever iterations that you keep over there. So that's all. So this is without position. Similarly, there is this same kind of algorithm, but this is with position. So in this, the only change is that here the x and the mean are going to be 5 dimension, having 5 columns. So this 5 columns is with respect to the different x and y coordinates of the particular image. So I have uploaded this particular code also, so you can check out how these this particular code gives results. So that's all for this particular video. Thank you so much for watching. Thank you.